Before I go on to our topic, I would like to share with you some of the resources that I've created recently. So one of it is the O-level physics formula. So in this blog article, I go through or I list down all the physics formulas that you need to learn from each topic. Okay, I've also provided a list of physics definitions here. So you'll find all the common definitions that you need to know for your O-level physics exams. And you can find them at this link here. So I provide the link in the description below. I also provide individual links for this blog post on the O-level physics formula and the O-level physics definitions. Okay, so now let's go back to our topic. So the best way to look at what is tested is by looking at the syllabus. So here we are at the syllabus, the O-level physics syllabus, and let's look at the syllabus to see what is tested in the topic on current electricity. Okay, first in part A, you need to know the definition that current is the rate of flow of charge and also you need to know that the units for current in amperes. So current is a rate of flow of charge. This is a definition. I've included this definition in the list of definitions that you need to know. Okay, I will share it in the list in the description below. Next, you need to be able to distinguish between convention current and electron flow. Convention current is basically the flow of positive charge, while electron flow is the flow of negative charge. So these two are in opposite directions. So let me give you an example. So this is a battery. Okay. Okay. So the longer part of a battery is, oops. Okay. Okay. So let me draw this again. So this is a battery. The longer end of the battery is the positive terminal and the shorter end is the negative terminal. Okay, so let's assume I have a lamp here, a resistor here, okay, and a switch here. So now I close the switch. So this is a closed circuit, so the current will flow. So if I'm talking about conventional current flows from this positive terminal here and back to the negative terminal. Okay, but it is actually not the current that is flowing, it's actually the electrons that is flowing. So if we talk about the direction of flow of electrons, then it will be from here, the negative terminal of the battery, back to the positive terminal of the battery. Okay, so this is the conventional current versus the electron flow. In part C, you're asked to recall and apply the relationship charge, which is Q, is equals to current, which is I times time. Okay, so this is basically a formula that you need to know. Okay, okay, then you need to solve questions using this formula. In part D, you need to be able to define e.m.f or electromotive force. So the definition is work done by a source in driving unit charge around a complete circuit. Okay, then next you need to calculate the total e.m.f when several sources are arranged in series. So if you have several sources arranged in series, then you simply add them out to find the total e.m.f. So for example, if I have a 3 volts battery and a 6 volts battery, and I connect them in series. So the total e.m.f here will be 3 plus 6, which is 9 volts. Okay. So in short, if you have several sources that are arranged in series, to add up and find the total in to find the total in EMF, you basically add them up. In part F, you need to be able to state that EMF of a source and the potential difference across circuit components are measured in volts. So basically, you need to know that the units for EMF and potential difference is volts. Okay, then next part G, you need to be able to define potential difference. PD is potential difference. So define potential difference. It is basically the potential difference across a component in the circuit is the work done to drive a unit charge. A unit charge is basically 1 coulomb of charge through the component. Okay, next, okay, I'll scroll upwards. So next, you need to be able to use this formula, resistance, which we usually denote it as R, is equal to potential difference, which is V, divided by current. Okay, so you need to know and apply this formula R equals to V over I, or you can also use it as V equals to I times R. Okay, so in part uh, you need to be able to apply R equals to V over I to new situations or to solve related problems. So if you are given the potential difference as well as the current, you will need to be able to find the resistance, or you are given two of the quantities and you need to find the unknown. Okay. Next, you need to be able to describe an experiment to determine the resistance of a metallic conductor using a voltmeter and an ammeter and make necessary calculations. So basically, right, remember R equals to V over I. To find the resistance, what you need to know is to find the potential difference across the metallic conductor and to find the current flowing through it. Okay, and once you know V and I, divide V over I and you will get the resistance. Okay, take note that for a voltmeter, to measure potential difference, you always use a voltmeter and it is placed parallel to whatever you want to measure. To find the current through a metallic conductor, you use an ammeter and you connect it in series. So let's assume that I will have this resistor here and I want to find the resistance. So I will connect it. So what I'll do is perhaps I'll feed it to a fixed resistor. Okay, connect it to a battery. Okay, and I will put an ammeter. So we denote ammeter with A and a circle. So this is the symbol for ammeter. And if this is the uh metallic conductor whose resistance we want to measure, what I'll do is I'll place a voltmeter across it. Okay, so what I'll do is I'll take the ammeter reading and the voltmeter reading and I'll take V divided by I to find the resistance of this. So typically to do an experiment, we will conduct more than one experiments, right? So we won't use a fixed resistor, rather we will use a variable resistor. So we will vary the resistance here and take the V and the I readings. Okay, and then we'll plot a graph of V against I. Okay, and the gradient would give us the resistance. Okay. Okay. So now that we are done with J, let's take a look at K. So in K, you're asked to recall and apply the formula for effective resistance of a number of resistors in series and in parallel. Okay, so if you have resistors in series, you simply add up the resistance to find the effective resistance. If the resistors are parallel to each other, so for example, I have two resistors here. This is R1 and this is R2. To find effective resistance, I'll make use of this formula. 1 over R effective is equals to 1 over R1 plus R1 over R2. And from there, I can find the effective resistance. So this is for parallel. Okay. Then next, let's move on to L. So L is basically record and apply the relationship between resistance and length and cross-sectional area, blah, 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 blah. So what this is trying to say is that resistance is equals to resistivity, which is the property of the material, times L over A. So L is the length of the wire and A is the cross-sectional area. So what it tells us is that the longer the length, the greater the resistance. The bigger the cross-sectional area of a wire, the lower the resistance. So for the same material and same length, okay, this wire on top, this wire here has a lower resistance because it has a longer cross-sectional area. Okay, if I have two wires made of the same material with the same cross-sectional area, the one that is longer, which is this one, will have a greater resistance. Okay, and so this is what L is all about. Okay, And for Ohm's law, you need to state Ohm's law. So this is another definition that you need to memorize. So basically, Ohm's law says that for ohmic material, the potential difference across it is directly proportional to the current passing through it, provided that other factors like temperature remains constant. Part N, you need to describe the effect of temperature increase on the resistance of a metallic conductor. So generally, when temperature increases, resistance tends to increase. Next, in O, you need to sketch and interpret the I. So let's look at the last item on current electricity. So in part O, you need to sketch and interpret the IV characteristic graph for a metallic conductor at constant temperature, for a filament lamp, and for a semiconductor. So let me draw it out. So for this is a IV graph. So for IV, so the gradient of the graph is equals to 1 over resistance. All right. So if I have a metallic conductor at constant temperature, okay, it is an ohmic conductor. So V and I are directly proportional to each other. So it should be a straight line passing through 0. Okay. Next, for a filament lamp, so for a filament lamp, okay, when I increases, the resistance will increase. Okay, so in other words, right, the gradient will decrease with increasing current. So it looks something like this. Okay, then for a semiconductor, so for a semiconductor, typically, okay, when you are at low voltage, there is no current passing through. Okay, then when it exceeds a certain threshold, suddenly the current is able to flow through it. Okay, so it will look something like this. Thank you for watching this video. Do subscribe to keep updated with our latest videos. And if you are interested, we do have an entire playlist on all the topics tested in physics O level, where we share with you what is tested in detail. Okay, in addition, if you want to learn in detail, do check out our courses on Udemy. Bye and see you.